Okay, so let's take a look at this combined work problem. And once you get the hang of these problems, they're pretty similar, right? They just involve a rate and then times time is equal to some amount, right? So an example of a rate could be kilometers per hour and time would be in hours. And so if you multiply the rate with the time, you get an amount in kilometers, right? Or it could be if you're getting paid a certain rate, so a certain number of yen per hour, so times hours, you get an amount in yen, right? Or dollars, whatever currency we're talking about, right? The tricky part with these problems is the fact that you have to set up an equation, set up another equation, and then set up a combined combination of the rates, and then solve for some amount of time. That can get a little bit tricky. So why don't we take this bit by bit, shall we? So the problem reads, two friends share a paper route, and they're telling us that Sheena can deliver the papers in 40 minutes. So that means she goes around her neighborhood and then comes back to her starting point. And so she's delivering papers or flyers or whatever to different homes along this route. And so she completes this task in 40 minutes, right? So what would that look like as a rate, right? Well, it would be one route per 40 minutes, right? And if we wanted to multiply that, we can use dot or x, right? One route per 40 minutes, let's say she works 40 minutes, right? Well, then what would happen to the units? Well, minutes cancel out, and then 40 cancels out with 40, right? And so that would give us one route, yeah? And let's say, okay, so her rate is one route per 40 minutes. What if she works, or what if she takes 80 minutes? We know that ordinarily she takes 40 minutes, but suppose she decided to take 80 minutes. Well, again, the units would cancel out. We would get 80 divided by 40. We would get two routes. Okay, so the key here is we understand that regularly her route or her rate is one route per 40 minutes. So why don't we just write this down again. One route, okay, per 40 minutes. Let's consider the case where t is unknown, right? Time, right? So let's just say times t minutes. Well, again, minutes cancel out, but this t is unknown, so this would be just t times 1. So we would get t routes, right? It could be one route, right? If t is equal to 40, right? But maybe t is greater than 40, or maybe it's less than 40, right? Maybe t is 20 minutes, right? In which case you would only complete half a route, okay? Sorry, t over 40. Yeah, t over 40, right? Because the 40 can't cancel out with anything up here, right? So this is her amount that she would complete if we allow t to vary, right? Okay, so it might be useful to set up a table here, right? So ordinarily her rate is one route per 40 minutes. And ordinarily her time, it would take her 40 minutes, right? And so if you do this times this, you get one route. But as we saw before, if we're not going to designate this t with 40, assign 40 minutes to t, if we're just going to allow t to vary, then her amount would actually be t over 40 in terms of routes, right? Or route, yeah. For Jeff, okay, they're saying Jeff by himself, he can cover the very same route in 50 minutes, okay? So then that means we would have one route per 50 minutes, right? And again, ordinarily, the time would be 50 minutes to complete that task, right? And so if you do this times this, the 50s cancel out, the minutes cancel out, you get one route, okay? okay? But if we don't use 50 minutes as t, if we use t greater than 50 or less than 50, just any value that's not 50, then you would do one route per 50 minutes times t minutes. The minutes would cancel out, but you would get t divided by 50. And it would be in terms of routes, or one route, yeah. So the question is, how long would it take them to complete the task, just one route together? Okay, well, what are their individual rates? Well, Sheena's rate was one route per 40 minutes, so 1 divided by 40, right? And Jeff's was 1 divided by 50, right? One route per 50 minutes times t. We could also just distribute and write t over 40 plus t over 50 because that's their amount that they would cover if t were to vary. This must be equal to 1, right? Because we're interested in determining, right, how long t, right? This is the question. What does this have to be in order for them to complete a single route working together? Okay, so we go, all right, well, why don't we distribute? Okay, so we have t divided by 40 plus t divided by 50 is equal to 1. Okay, and so what we can do is we can say, you know what? We've got ourselves a rational equation here. It's not too complicated, but it's a rational equation nonetheless, right? And so we need to ask ourselves, what's the lowest common denominator, right? We don't have any non-permissible values here because we don't see any values of t that would cause an issue. And we go, okay, well, you know what? 40 and 50, well, they go into 200, right? That would be their lowest common denominator. So why don't we multiply both sides by 200? So I'm going to multiply this by 200, I'm going to multiply this by 200, and I'm going to multiply this by 200, okay? So I can just get red, right? So 200 times t over 40 plus 200 times t over 50 is equal to 200 times 1, right? And so really this is just the same thing as like 20 divided by 4, right? That would give us 5t, okay? And then over here, this is just like 200 times t over 50, or in other words, 20 divided by 5, which would be 4t, okay? And this is equal to just 200 times 1, so 200. And so this would give us 9t is equal to 200. And this is easy, right? We just need to divide both sides by 9. So t is equal to 200 divided by 9. And since they said they want it to the nearest minute, this would be approximately equal to about 22 minutes. Okay, so this would be our answer. Okay.